What I'm noticing more and more in the industry is, of course, there's an engineering aspect of making the equipment to print everything, right? To actually like accomplish the printing aspect. But I think it's the material science behind the inks and the mortars and the resins that have come so far and that are really identifying how the engineering of the equipment has to work.
Hey there, everybody, and welcome to another episode of the Orthopreneurs Podcast. I'm Dr. Glenn Krieger, your host. This is episode number 13,004. No, I'm kidding. It's not episode 13,000. I think we're somewhere in the 300s is my guess. But you know me. You know I love technology. You know I love to push the boundaries. I love to hear about things that are a little bit different, unusual, things that can help us in our practice potentially. And so today, we've got a really great guest, Mike Gordon from 3DNA Dental. Welcome, Mike.
Thank you so much. Thanks for having us.
It's my pleasure to have you here. And, you know, the technology that you help orthodontists with has been used in many other segments. We're going to talk about that later. You've been 3D printing forever. And some of the stuff we're going to talk about really does push the envelope in a really good way. But we'll get into that a little bit later. Before we do, let's start with you. If you want to tell us a little bit about yourself, you know, give us that 60 to 90 second elevator speech. It's a tall building. You got 60 seconds. Tell us a little bit about Mike Gordon, how you ended up where you are, a little bit of your background, and tell us a little bit about 3DNA Dental and what it is you guys do.
I've been in IT my whole life. I sort of landed in it as a very young child. My school got a grant when I was in like 7th grade for a bunch of tech stuff, and I ended up being one of 2 students that just got hired actually temporarily by the school, and then got credits as I went through school to help install, maintain, and just sort of implement all that tech. And I just never looked back from there.
Right on.
3DNA Dental, basically, I got into 3D printing around in 2012 and been looking for a way to sort of have 3D printing as part of my professional services. And about 3 years ago, a couple of GPs contacted me to help implement 3D printing in their dental practice. And it just became very clear that the learning curve, not only to like figure out what to buy, how to implement, like which equipment to implement, because by choosing equipment, you're often choosing what resins you're going to be able to use, which really ends up being extremely important in dental. And especially because things are changing so quickly, right? But either way, what it came down to is there's obviously a huge learning curve to implement 3D printing. And we see so many amazing companies starting around 3D printing in dental. But one of the things that is always lacking or seems to be continuously lacking is having real support, ongoing support for in-clinic adoption, where if we're really going to be serious about this, and especially for mainstream adoption, right? A lot of early adopters, there are a lot of tech savvy sort of younger dentists or just dentists who happen to be really passionate about it, and that's great. And those are people we've been working with, and we love working with those people. But if we're going to move towards mainstream adoption, I think the idea of 3DNA Dental is to help that be able to happen through really ongoing support and workflow implementation.
Very cool. So just to be clear for anybody out there listening, does 3DNA Dental sell printing equipment, 3D printing equipment? So if I'm somebody who says, look, I guess there's 2 people I'm asking for. The first one is the person who says, you know, Mike, I've been around 3D printers my whole life, you know, not my whole life, obviously, but I've been around them for a while. I understand them. I played with a whole bunch of different models. I understand what they do. But, you know, the idea of doing some of the stuff we're going to talk about in a little bit really appeals to me because everybody out there is already assuming we're just talking about printing models and doing suck downs. And that's not what we're talking about here. We're going to talk about something a little more exciting. But I say, you know what? I got 3D printers in my office. I kind of know what I'm doing. Are you a company that can help with those people in terms of bringing them up to speed, implementing them, helping them understand how to do what we're going to talk about? And what about the person on the other end of the spectrum who goes, look, you know, I've heard about 3D printers. I really haven't bought one yet. I know I've got to get one at some point. I don't quite understand why I should get one because I've been doing just fine. I'm working with my, you know, insert, you know, external aligner company here, right?
Right. Yeah,
I've been working with whomever to do all of my aligner cases. And, you know, I guess I want to dip my toe in the pool and play with it a little bit. Can you help that person too? So if you don't mind addressing those 2 and how you work with them, I'd really appreciate it.
Absolutely. Yeah. I mean, one of the things that I would definitely stress is that we're all about sort of meeting the needs of the client, like exactly. So depending on where you're at with it all, we can fit our services to your needs. I do think that 3D printing has gotten a bit of a bad rap for exactly that reason, right? We've sort of covered it, but it's like being somebody who wants to implement a specific workflow, who has any troubleshooting issues in the beginning, it might end up just being a piece of furniture for you. And that's been a big turnoff for a lot of people who want essentially the ability to copy and paste a successful workflow into their clinic, right?
Right.
And that's exactly what we want. So for people who have a lot of 3D printing experience, we offer just sort of like a la carte, piecemeal, like hourly training for workflow implementation if you're interested, or even free consulting about, let's say you're doing dentures currently, but you want to move to you're worried about a resin not working as well as you'd like, or you want to know if there's something with stronger attributes or material properties available. Those are things that we're just really interested in, and we can help disseminate that information to you and train you and your staff on how to implement those workflows. And then if you have no 3D printing experience whatsoever, we can start from scratch. I mean, we have a whole course on like intro to 3D printing, how do 3D printings work, like how does it actually work, why is it advantageous, and then all the way to like you want to do all on X and immediate restorations. We can help with that. So it's really just what your clinic would benefit the most from. We can help with that, with the implementation of those workflows. But yeah, for sure, one of the most unique products that we're repping is the direct print clear aligners. And I think
you let the cat out of the bag, so we might as well talk about it.
I can't help it. It's so exciting.
Print 3D aligners, right? So that's why we're talking about. For many people out there, they're used to the concept of, let me go get third-party software, which you're still going to need. I'm going to stage a case, or I'm going to scan it, I'm going to stage it, and then I'm going to set it up, and I'm going to print out 10 models, 8 models, 12 models, whatever it is. Then do my suck downs,
probably
do my trimming, my polishing, right? My wash, my cure, the whole 9 yards, packaging. And that's what people are used to for what we'll move forward referring to in this interview as in-house aligners, right?
Traditional in-house aligners.
Yeah, traditional in-house aligners.
Right.
The model you're talking about is put it on 3D software, set up what you want, have it stage, so it sets up how many steps it's going to need, and then directly 3D printing the model on the 3D printer. So direct print the aligner on the 3D printer, so that all you have are the little stalks for the 3D printing that are on it. So you can pop those off, polish it in 2 minutes or less, and call it a day.
Yeah, and the supports have tip thicknesses of like 0.2 millimeters, so they literally just pull right off. And then after curing, the polishing is very fast per aligner. So, but yeah, I mean, it's incredibly fast. I mean, like if you've done any 3D printing at all, you can imagine the labor savings from that perspective already. Obviously, the printing models is huge. Doing the physical suck down or vacuum forming is huge. And then on top of that, the trimming, like the margin line trimming is I think one of the hardest parts, because, using those either bleach tray scissors or whatever you're using is a huge thing for your staff, right?
Sure.
And then what I think is actually more interesting to talk about beyond the labor savings and the cost savings, because by the way, your cost per tray is going to drop significantly here compared to in-house aligners currently. But what's really exciting is the material properties are amazing, right? You could never have had shape memory in a plastic before without 3D printing it in some sense, right? So the reason I don't know if you want to get into this, but the reason we have the ability to have shape memory is the act of printing in layers. You're connecting a long chain polymer, so you're doing long chains by your XY axis to monomers that are connecting each of those layers together. So you're creating like a structure. It's almost like you ever see like in a ship, the rope ladder that they use to go up.
Yeah,
it looks like that. And I think that's really the story here, is because when you combine the transition temperature, so like at body temperature, this material wants to return back to its printed shape at the ideal tooth force movement of around like 1.5 newtons, depending on a few factors like the thickness of the aligner and mainly the surface area that it's touching, right? And because you're able to do that, you're also not getting rid of your undercuts. Whereas before, with a suck down of any kind, you had to do blockouts, right, in your inner proximals, so that you can pull that tray back off and get it back onto the teeth of the patient. And in this case, we don't have to do that, so we get complete tooth surface coverage, right? Like we're touching everything on your tooth. And then when we go up your margin, like when you go up your gingival margin some, you're getting like even more tooth force movement, right? So I think the material properties are really the most exciting part.
I mean, you just covered a massive amount of information that we have to go dive back into.
Let's do it.
So let's go one step at a time here. So the first step is talking about direct printed aligners, right? We're
Right.
not talking about printing out a model.
Right.
And as you and I have talked about previously, not here, but offline, we've talked about the fact that, 3D printing or traditional in-house aligners have not worked for a lot of people
Right.
for the reasons that, they got to have somebody who's going to set it up on the platform, which is fine, right? And then they have to have somebody who's going to make sure the printers are all working fine, which you still need. But then you need somebody who's going to take it out. And if you have 10 aligners, it's 10 models. That means 10 blockouts potentially, taking off 10, washing, curing, doing all this stuff, which you have to still do anyway. But
Actually, it's
you don't
very
need to.
well, we'll go into it, but yeah, no, I
Yeah.
mean, the difference is massive, right? Like the number of steps is reduced by about half, just in terms of the number of steps. But then each of those steps, the ones that were taking the longest are gone, and the ones that are left are more efficient than ever before. So
Right.
the reason I stopped you there is one of the really cool, unique things about Graphy, and I think what's going to end up being the gold standard in 3D printing as time goes on, is we're not cleaning in isopropyl alcohol anymore. We're not etching our layer lines anymore, like to show all that sort of imperfection. We're leaving the exterior of it. We put it into a heated centrifuge so that we wick off and have a very even, thin coat of resin left over. And then when we cure it in nitrogen or in an inert gas of some kind, an inert environment, so that you don't have that oxygen inhibition layer. And that allows you to have a much smoother surface on the outside, and it becomes more transparent as well, right? Because you're not seeing all those layer lines. But you also just removed a step where you're waiting a long time for something in the isopropyl bath, usually like 10 to 20 minutes, depending on what you're doing, right? This is a 5-minute centrifuge, and you're taking that straight out, pulling off your supports and putting in the cure, and all that's left is a quick polish, and now it's time to package, So it's a much improved workflow, I would say, from just saving labor for sure. And it also just, I think the result is, it makes more sense. Like everything is very physics driven, right? Like we're trying to be more efficient.
So how long has this process been around?
So Graphy, I want to say Graphy started in around 2017. And then this particular process, I don't know exactly when their FDA approval happened, but it was more than 2 years ago at this point. So they have over 100,000 cases in circulation already.
Wow.
Internationally. Very, very, very few in the US.
So are there any studies out there, as far as you're aware, that talk about the effectiveness of the shape memory of this plastic? And if
Absolutely.
there are, can you talk about that a little bit?
Yeah, I mean, my focus for sure, I want to be clear, like my background is in IT, and I do not have a dental background more than the last few years and all the work that I've been doing to help implement all this stuff. But we have 20 articles that go over not only the material properties and why they're advantageous, but also like because there's so many cases already in circulation. If you're really interested in seeing more of the clinical understanding of why it's so advantageous, for example, they have several KOLs that a lot of people are aware of. Dr. Kenji Ojima is a really good one to follow because he's moved almost exclusively to using the Graphy aligners, and he actually has started to, one of the major things about this is that it's hugely reduced attachments, right? Because you don't have that blockout and you're able to make full tooth contact, you're able to do a lot more with next to no attachments. So the studies that are available they talk about, all of those things, as well as the physics and why the material properties are so strong. And I have, like I said, I have a link to 20 articles that I can share with anybody interested. I don't know how to go over them properly in this format, but
I don't think you can.
Yeah, it'd be hard to.
Do we know what the cost per aligner is? What are we estimating cost per aligner?
So just in material cost per aligner, it's somewhere between like $4 to $6. So it really depends. Like when you take a bottle, it's a kilogram bottle of resin. So the question would be how many aligners can you print with that? Graphy I think very conservatively says somewhere between 110 to 120 aligners per bottle. In my experience so far, it's been considerably more than that. But either way, if you did that math at the cost per bottle, it comes down to somewhere around like $4 to $6 per aligner. So that down from the national average as of LMT, according to LMT magazine, is like $56 per aligner, is the national average currently. I think
Wow.
that most people probably are used to paying a little less than that, but it's still much, much higher than that.
When someone prints these, I assume any 3D printer will work, or are there only specific 3D printers that will be able to do what we're talking about here?
From a technical, like, so Graphy is capable of printing on probably 5 printers currently that already have. So really what it comes down to is having a material profile made on the printer for that type of resin, right? So it's like, how long per layer does it need to be exposed at this thickness, and optimizing that. Graphy will no longer be updating material profiles for any other printers but a specific printer. And that printer they chose that printer on purpose because it's the fastest printer on the market.
Which
So
printer is it?
it's from the company called Uniz. It's called the NBEE. So I highly encourage people to look it up. From my perspective, that's really where my interest starts, anyways. Right, is in the physics of the machine, and it's just an amazing machine because it combines the LCD technology. So it's a monochrome LCD, which
Wow.
gives you that native pixel resolution, right? The really, really high accuracy all the way to the edge of the print, which is sort of one of the downfalls of the more of DLP printers, which is the other version. And what's been lacking in LCD printers for a long time is the light intensity. Like, how do you get enough light intensity from an LCD panel, right? It
Right.
doesn't compete with DLP. But what they have is they have a monochrome LCD with a collimated backlight from underneath. So it's a liquid cooled LCD because otherwise it would get too hot, with a 16 milliwatt per centimeter squared backlight underneath it, which is like 33% stronger than the best DLP printer in dental right now. So it's incredibly strong in terms of light intensity with incredible accuracy. So it's really the best of both worlds.
What's the cost of that printer, give or take? I'm not going to hold you to it.
11,000.
How much?
11,000 for the printer itself.
There's a reasonable amount of investment at the beginning to get involved.
Yeah, I mean, I guess it depends on what you're comparing it to, right? Because, if you compare what your cost per tray is currently, and if you were to implement this technology in your clinic, the savings would be, especially if you go off the national average of $56 per tray, the savings is so massive that that initial investment might be, very much comparatively really very small, right?
Yeah.
So
Now,
I think it just depends on when you first implement a technology, especially if you're not using a company that can really help you copy and paste it successfully, you have to sort of think like, well, not only do I have to buy this equipment, but I have to, basically work from scratch to get this implemented in my clinic. And I think that's where those costs start to really add up very quickly, right?
I just want to take you off topic for just a second because
Sure.
you mentioned something to me earlier. Again, before we started doing this, you told me about construction
Yeah,
and concrete printing. I have
that's
to
right.
add, I've seen it. I've seen the size of those printers, and it's absolutely incredible. Can you take just a moment or two and talk a little bit about that kind of printing and any other kind of printing that's 3D printing that's kind of cool? Because the geek in me kind of hears concrete printing. They're
Oh yeah.
printing buildings, right?
Oh yeah.
How exactly does that work? I need to understand it a little bit better.
Funnily enough, it's not all that different. Like what I'm noticing more and more in the industry is like it really is of course there's an engineering aspect to making the equipment to print everything, right, to actually like accomplish the printing aspect, but I think it's the material science behind the inks and the mortars and the resins that have come so far and that are really identifying how the engineering of the equipment has to work. But either way, so for concrete, I think that one of the most exciting things is not so much like you can the classic example of 3D printing, the most hobbyist adopted type of 3D printing is the FFF, or the sort of gantry style print head with that heated nozzle, and it spits out you have a roll of plastic and it spits that out
Right.
layer by layer. Well, that's pretty much how concrete 3D printing works, almost exactly, right? Most of the biggest concrete companies are still doing it in the way where they have like a massive gantry, crane that they set up on the job
Right. I've
beforehand,
seen that.
which is still like I'd say like 56% of the printed buildings currently are using those types of technologies. But what's really up and coming in concrete is getting away from needing to have like a 7 to 10 day setup time, right? Creating this crane on site for a house, which is like a considerable cost to just like temporarily set up a crane, right?
Right.
Instead, they have these mobile vehicles that literally are able to like, I don't want to say vehicles, but like a mini crane or a type of printer that's meant for this specific application, and they're meant to be able to like actually fit through a standard doorway, right? So they can drive out of their own print job when they're finished. And what happens is they sort of unfold. They have legs that come out, for example, and they unfold, and they're able to do like somewhere between like 30 and 45-foot circles of printing in one print. And then you just move that printer to the next part of the pad, and it prints the next 45-foot circle up to 10.5 feet tall, for example.
Oh my God.
And then after it finishes printing all your downstairs walls, it's printed in a way on purpose where you can set flat sort of pre-made molds to go across as your roof line. And then you crane your printer onto the next floor and you just keep going. So like there's no limit in terms of how wide you could go, and there's no limit really on how tall you could go, right? But the reason I talk about the materials is like even in concrete 3D printing, what's interesting is we're trying to move away from concrete. We're trying to move away from cement altogether, because cement is one of the worst things for our greenhouse gas emissions in the period, really. But in construction, it makes up a massive percentage of our greenhouse gases, is just creating concrete or creating the cement in concrete, really. So geopolymers are the next big thing, right? And we're just a few weeks ago, maybe a couple months ago, the first geopolymer printed building was made in the United States. So it's like the whole world around this, around additive manufacturing, is hugely about materials. Another one I want to mention real quick, which is much more dental related. Obviously, you interviewed someone not too long ago about their metal 3D printers. It's a lab that was pretty progressive.
Yeah.
They're printing in titanium, right? The next version of titanium that's getting really exciting is graphene reinforced titanium, which makes it massively, massively stronger. There's some questions about biocompatibility, but since it's just pure carbon, I would think that in the long run, we're going to be able to figure that out. And then there's another company called Lithos that I'm really interested in that's printing in hydroxyapatite, printing in bone, right? It's a ceramic printer, but they're able to print in bone, and they have to fire it in a kiln. But when they're finished, I mean, imagine the types of implants we can make. Imagine things that you could never have CNC'd, right? Like the type of structure and being able to, even in teeth, right? Like if we can represent the outside enamel, really hard, strong surface, but then on the inside, we do something more like dentin, where we have a lot of less density, essentially what it comes down to, right? And we can replicate material properties of just about any kind we want, right?
Printed 50 microns on the outside and 150 microns on the inside.
I mean, these printers, by the way, go down to 10 microns. We can do 10
I didn't know the tolerances,
layers.
But I figured it was low.
Yeah, 10 microns in the z-axis, but your XY is what you're really worried about, right? Like your native pixel resolution, you're still going to be around like 50 microns currently.
And the thickness of the layer doesn't really matter as much to me in the z-axis.
Yeah, the z-axis matters in the sense of how fast you're going to print, right? But
you said it at 10 microns. You might as well go home, have dinner, sleep, wake up the next day, run a triathlon, come back, recover.
It's actually not as bad as it sounds, because like when you have thinner layers, you also expose them for less time. Right. So it's not like it just literally goes by that much. But yeah, it definitely takes a lot longer.
Yeah, it's like slicing the pastrami thinner to build a sandwich. You get it right. You just stack them. It's less to build, but
it changes the taste, right? Yeah.
I mean, it's totally different. Yeah, it's amazing.
And that's the same, like in material properties, it's just amazing. Like when you get down to it, it's like the smaller you start, the better your results. You know what I mean?
Wow. It's amazing. Really I love your passion for this. I think you and I may have geeked out a little bit more than some of the people who are listening would have, but it's fine with me. I don't care. It's my podcast and you're here with me, so we can have as much fun as we want.
Yeah, let's do it.
As we're winding things up, I just have a question for you.
Sure.
I think you explained it really well. I think everybody out there understands exactly what 3DNA Dental does and the advantages that you bring to the table. If someone wants to get a hold of you, what's the best way to reach out to learn more, to either schedule a demo or to learn more about it or to just get help? Where should they reach you?
Yeah, 3dnadental.com is for sure an obvious one.
And just so, because it went fast, 3dnadental.com.
we're working. So a lot of people in ortho should have heard of Paul Wilkins. He's our director of sales, and he's incredible. So if you know Paul, reach out to him. If not, we're going to be sending you a graphic. We spoke with your one of your helpers, and we're going to send you something you can post up. But essentially, I'm happy to share my information. It's mike@3dnadental.com for my email, and then 808-357-1323 for my phone number. So please reach out if you're interested at all. But again, we're just really passionate about 3D printing, and we know that in order for it to be truly adopted and adopted successfully, there needs to be a long-term solution to essentially like your IT department now, right? Like you don't just expect all your equipment in your clinic to work. You need some kind of a plan on when things go wrong, and that's exactly what we are, specifically for in-clinic 3D printing.
Mike, I can't thank you enough for being here today. Appreciate you a ton. If you guys are at Summit later on in the year, people maybe will come up and talk to you about it there. They'll have 3 days on a cruise to learn everything there is to know. So
what a great idea, by the way. I love it.
Thanks. I always tell people Summit is really about what I want for me. I mean, look, I'm being dead honest now. Like, people think I'm making this up when I say this. From everything from a podcast episode to the speakers at Summit, to the venues, to locations, right? To the way it's set up, to the surprises, the fun, the swag. Every single thing we do is something that I personally want or want to hear. For me, it's the only way I know how to live. I'm not very good, my wife will tell you, at guessing what other people are thinking. I'm actually really bad at it. But everything I've ever done for my life that I thought was worthwhile, I've brought out to others. And when I do a podcast with someone like you, it's because I think what you have to share is awesome and I want to learn about it. And I figure some people are going to want to, some people aren't, but maybe the next podcast episode they want to learn about. That's the secret to success, I guess, is just endless energy. and to do things that, you hope are going to help people and that you enjoy doing. And I think the one thing we have in common here is that that's exactly what you're doing with 3DNA Dental right now. It's something that's helping people that you're passionate about. You love doing it. It shows through. And with those two things in mind, how could you possibly fail, right?
I think as long as we plug away long enough, you really are useful in trying to help people, I think it's inevitable. And I've had that experience so far in life and been very lucky. So I just hope that we can continue.
I appreciate you being here. Just wish you a great day. And if you need anything, reach out. But everybody out there, you got his contact info. Reach out and ask any questions that are on your mind. He's here to help you. And thanks again, Mike.
Thank you so much, Dr. Krieger. Appreciate it.